One of the things that you will be doing multiple times in this gas laws unit is converting between units, and that will be done for both pressure and temperature. There are 3 different units that you'll see for pressure. The first is atmospheres, and that's abbreviated ATM. The second is kilopascals, kPa, and the third is millimeters of mercury, mmHg, and you should recognize that Hg as the elemental symbol for mercury. The 3 numbers that you see up here with their units are the equivalencies for atmospheres, kilopascals, and millimeters of mercury. So if you're going to convert from one unit to another, it's these 3 numbers that you'll need to be using, and we're going to show you how to do that using the unit factoring method. So for example number 1, we're going to convert 2.65 atmospheres into kilopascals. So we're starting with units of atmospheres, and we're going to multiply by a ratio that will give us the units that we're looking for, and so that's kilopascals, so therefore they're going to go on the top. Because we're trying to get rid of the units of atmospheres, ATM, those now need to go on the bottom of this ratio. Now what goes into this ratio are the numbers that you see up above for the equivalencies. So for kilopascals and atmospheres, 101.325 kilopascals will be equal to exactly 1 atmosphere. So when you do this calculation, you're now going to multiply 2.65 times 101.325 and divide it by 1. And on your calculator, you'll see a number of 268.511. And we want to put that into significant digits. From our question, we have 3. So your answer should be 269. And that's now units of kilopascals. Our atmospheres have canceled. The second example, we're going to start with millimeters of mercury and change that into atmospheres. So starting with the 394 millimeters of mercury, again, we're going to use unit factoring, so we're going to multiply by a ratio. And to cancel the millimeters of mercury that we already have, we want to put millimeters of mercury on the bottom of the ratio, and the units that we're looking for, which is atmospheres, onto the top. So again, from those equivalencies that you see above, 1 atmosphere is equal to 760 millimeters of mercury. So those are the 2 numbers that get put into the ratio. Now multiply your 2 top numbers, so that's the 394 and 1.00. Divide by the 760 that's on the bottom, and your answer, with the correct number of significant digits, is 0.518. And again, if we look at units, millimeters of mercury have canceled. We're left with atmospheres. Now let's look at temperature conversions. When you're doing calculations that involve temperature in the gas unit, they must be on the absolute temperature scale, or the Kelvin temperature scale. Absolute 0 is considered the lowest possible temperature, and that's 0 Kelvin. That's equal to negative 273.15 degrees Celsius. So again, there's our equivalency that we're going to use, except this time we're going to be adding and subtracting to convert between Celsius and Kelvin. In example number 1, if we have 22.4 degrees Celsius, and we want to change that into Kelvin, we are going to add 273.15. And that's going to give us 295.6 Kelvin. Because we're adding, we want to keep the same number of decimal places, which is why we have 295.6 as our answer. Second example, this time we have kelvins. We want to change that into degrees Celsius. So 350.42 Kelvin. This time subtract 273.15, and that will give us our answer in Celsius. So on your calculator, you should get 77.27. We want to keep 2 decimal places for that calculation. Remember that your Kelvin temperature always will be above 0, and it will always be larger than its equivalent Celsius temperature. There are 2 sets of standard conditions that you're going to come across in this unit quite regularly, and you should know what those are. In fact, you need to memorize what the temperature and pressures are that go with these conditions. STP stands for standard temperature and pressure. So if you see that in a question, that's telling you that the gas is being measured at 0 degrees Celsius and a pressure of 101.325 kilopascals. SATP stands for standard atmospheric temperature and pressure, and that's a gas that's measured at 25 degrees Celsius and a pressure of 100 kilopascals.